Yeah, I got it.
Okay.
So I could just stick that in there and then it would power the Adreno. So we wouldn't have to worry about an extra battery. Now I don't know how fast that's going to drain our battery because now we're controlling the function
Right.
and everything is being controlled by that one battery. But that's fun. That'd be fun. I think we can do that. We should try to do that at Save Space. Definitely Save Space. But our the I went ahead and we can try the pulse width modulation and from the board to lower the circuit, but I mean I have the circuit already.
I mean, pulse width is probably better. Like you're saying, it's going to be more repetitive. I was just thinking of like a more like rudimentary way of solving it. Say like for loop, control the voltage, create like that stop time in between, go down to 1.4 for however long you need it. But if you can do a pulse width, it accomplishes like going from 5 to 1.4, right? And just staying at that, not going below. It does the same exact thing.
Yeah, I just wonder why. So here's the thing: like the video that I sent you, multiple people don't use the pulse width modulation on the MQ7. It will read without switching it. Now here, but a good way to test it that I noticed that one person did was they took a candle, lit the candle, put a jar over the top of the candle, and let the candle burn out. So it took all the oxygen out of the jar, and then they quickly put the sensor under there. Now, when they did that, when it didn't have the pulse width modulation or anything, or it was not pulse width modulation, but their circuit had a voltage regulator. Then when they didn't vary that and follow the data sheet, the spike was at like 200 particles per minute. And then when they did the same exact thing and did it with the variation of voltage, it went up to like 420 particles per minute. So it must be it's a lot more accurate when it does that, but it still will work with it. Just like the way I have the circuit built right now, all you have to do is have power, the ground, and then the analog output going to the board, and then you just read the analog output. And I mean, that you can do that with the MQ136, the other sensor we have, because it doesn't need this variation of voltage. MQ7 is the only one that needs that.
Okay.
Now, so I went ahead because I mean, we can try that, but I went ahead and I looked up, like, we needed something with a source drain resistance of at least like 0.01. So this one has like is 0.046. And then like one person said that it can take AC or DC. This sensor can. So this pulse width modulation should work. So if we just put let me show you this schematic where
I mean, it's literally just a discrete, right? Pulse width modulation, like you're saying, it's discrete. It's not like a continuous signal. So technically speaking, it's kind of like it's like a DC, but like discrete.
So I think this is the way it should be set up.
I don't even, speaking on the MIT app, I've just ended up not even using the phone a lot. I just, because they have that emulator built in with the phone, like the emulator phone. So I don't have
Okay.
to like that. I end up using that a lot more instead of like, because it takes a long time for that emulator to start going or downloading the app onto your phone. So most of the time I'm just using the emulator, but I'm still trying to like fully, like I've gotten the basics of how to use it. But I'm gonna have to like watch that video, look at more sources on how to like implement a Bluetooth connection into there. Like it's pretty easy, it's user friendly. I just need to learn more. But
All right.
I don't think it's gonna take like stay like 20 or 30 hours or anything like that. Hopefully not. But I'll keep you guys updated on that.
I think that video I sent you
This
will
is good.
yeah, if it looks like you drag in certain block. There's just blocks, and if you connect the correct block,
Right.
then it knows to say that you're connecting service one Bluetooth to some certain signal,
That's
and you
awesome.
can it'll show you. It shows you
Okay.
exactly what
Yeah,
they're.
because looking at all those blocks, because like say I've creating buttons in the video on how to run it and like connect it. Those blocks are like your if then statements, all these logical.
Yeah,
Yeah, they like fit in. It's like a small like game or something. It's hard to describe.
that video will
And
show you.
okay,
It'll take in. It'll say whatever is printed. I have printing out on the serial monitor for this
okay,
thing. It'll print out. It shows you to just have whatever's printed out on the serial monitor basically print out on the app.
okay. I'll be
Either
watching it soon. I'll definitely be putting in a few hours into that today. Uh, but I also have an exam tomorrow morning at 8.
Oh,
Yeah.
well, I mean,
Me-
this is going to be just an interim report. Like,
Okay.
so I don't think we necessarily have to have it done with them, but I mean, I guess it would be nice.
This circuit, if y'all can see what I'm talking
Yeah, I can see
about,
it.
I ordered this.
Transistor.
Yeah, where that little blob just came out of nowhere. Um, yeah, so I ordered two of those. It was like $1.50 each, but I just did that probably a couple hours ago, so it hasn't even shipped yet. But if we do that, then it'll give us the most accurate reading for the sensor. The code's real easy. You just set baud rate, and then you initialize what input pin is, and then you say serial dot print that variable, and it will print out what it's reading from it's like 5 lines of code. Now we could mess with it with the pulse width modulation and see if we can get some of that voltage changes from one of the pins 9 through 13. It looks actually that 3, 5, and 6 also have the squiggly line, so it could be any one of those. It just has to be one that has that capability. And then what else?
That's just the Arduino, not the drive shield.
That's just the Arduino. Yeah, the drive shield is already on. This is what it basically. This is what is on would be on top of the robot, right?
Yeah.
If you
Right.
see
Let me
my
see.
regular screen.
Yeah, I'm gonna make. Okay. Yeah, that makes.
And the way this is plugged up is just the simple reading without the pulse width modulation. This just reads like it still reads, but it's not accurate. And then there's other sensors over here, and that one, like this one, does fine just with regular 5 volts the entire time.
Right.
This one needs to be. Now this would sit on top of the robot and in the under part on like say the bottom floor of it. It's got the motor driver and receiver down there, and then our battery is going to be sitting in between these two. So it can be this in the back of the bot, this kind of up to the front. Right here in the middle is our battery. The motors are on each side. And then right in the front part in front of these sensors is going to be where our camera will be.
Okay.
Now, since the battery's right there, or since this is over the Arduino would be over the top of the hole that goes to the bottom. It would honestly be easy to plug that into where the receiver plugs into for power, and we might be able to use that 5 volts. Is that coming out of the motor driver, like you were saying, because that 5 volts is 5 volts, and that's what's putting power to our receiver. So I don't see why
you might have to look at the amps that the receiver requires. It might be able to power both.
Didn't you say it was like 16 amps for the battery? Was the max one?
battery? Yeah, but see, we're plugging it into the motor driver, and that motor driver, the output for that 5 volts is only the amount of amps we need for this little bitty tiny receiver,
Right?
Which might not be enough for running the sensors and the Arduino. but we can try. And if not, then what we could do is run.
That's just like one of the ports. I'm gonna have to relook at that motor drive shield. Can you send me? Because I remember being able to output. I remember being able to output more than 5 volts on one of the motor drive shields I used for my Arduino projects.
I think you're thinking of this is just a motor driver, and it's not a motor drive shield.
Okay. Okay. So that must be something else. Because what I was using, because I was trying to output 9 volts at the time or more. Yeah, 9 volts at the time. And I had to buy a drive shield that was able to output 9 volts. And then that connects like to the DC motors, like say for the track.
Oh, hold on. I gotta move my truck.
Yeah, no problem.
This is the motor driver, right?
Okay, let me see. Oh no, that's really similar. Like you have your just does 5 volts. Ooh.
See this 5 and 0 volts is supposed to be. That's where the receiver.
See the one that I was using last time would go up to 12 volts.
The output to the motors is 12 volts.
Oh, okay. Right, but the ports is 5 volts.
Yeah, hold on, I'll be right back.
I see.
Right, because
the
port.
Hassan.
Yes.
Oh, I was going to ask if you knew, if I remember correctly, what was the last level decomp we did? It was level 2, was it?
Yeah,
was it
1? It was level 2. I haven't even.
Okay.
Is this for the cost tracking?
No, I was asking because he wanted us to talk about that during the presentation, along with how much we've spent so far and some kind of timeline. I think he said.
Yeah, level 2. We're gonna have to talk about that in a bit because I'm a little hazy on like what's
Same. I think Justin's the one who knows most about the decomp.
Yeah. God, what a weird semester, man. I don't even know what's happened. I'm mostly stressing about Jacob's class.
Yeah. Are you gonna actually go to the graduation ceremony? I don't know if you just got the email.
I think I just did. Is it gonna be online?
They said, from what I read, they're trying to do in person, but they are doing online as a backup.
Okay, isn't it the 13th
of December?
Yeah, I'm not. It's gonna be a hard one because the finals are the 24th of December.
No. We're ending early. It's actually in like November, the 20s of November.
Oh yeah. Okay. Yeah, November exams, the 13th. I might, if they would, okay, if that works out, I might be able to. But man, I don't want to be jam-packed to a bunch of people just like mouth breathing over each other. And
well, I mean, I think we'll be grouped together as in electrical engineering. There's not many of us.
I'm gonna wear a hazmat suit. I might be able to pull it off if I have nothing going around the holiday time. Because sometimes I travel to Florida during the holiday time. Like, I don't know, I've spent my last few Christmases down there. I'll see what happens this year. I'll try to, if they do it in person, I'll definitely try to go. But here's the thing, like, I don't know if my family's going to be able to show up as well. Like, that's going to be a hard one. Like, I just don't want to go to a graduation ceremony by myself. I mean, I know a few people have done it, but it's weird. Or like invite friends. That's another thing about you and me, man. Like we've known a lot of people who've graduated already.
Yeah.
Especially like last 2019 and like 2019.
I don't know many people here anymore.
Yeah, same. Like I remember I'm in these classes. I'm like, who's in there with me? Like besides like this senior design class, like I know just about everybody. But the people that I started out with, that I met like really soon, you're one of them. Justin's one of them for sure. But a lot of them have left or graduated. That's what I mean. I'm just trying to get through this class and Jacob's, dude. Everybody, I was looking at Jake. I texted Justin the class average on the quizzes and the homeworks.
Before you say anything you regret, we are still recording.
Oh, we are still recording?
Yes.
What do you mean regret? Oh yeah, okay.
Just in case.
Just in case. Oh no. So yeah, okay. I'm gonna keep my mouth shut. Great course. I love Dr. Jacobs. Best man in the world. Learning a lot.
Here, do we want to stop the recording?
I don't know. Is he still on?
Are you the one?
Are you the one who's scrolling through that, or is he?
I am.
Oh, you're back? Oh, okay. I didn't know you were back, man.
Yeah, I'm back. So, I mean, we can try it. I don't know if the 5 volts. Is it a 5-volt input to the Arduino? Because I when I hook
the Arduino, yes, the Arduino itself is 5 volts. Is that what you mean?
Out, though, but what I'm saying is, what's powering from our computer? How much? When I plug this up and it shows power from the computer, how many volts is going in there? Because when I plug it up with my little special adapter thing that I have in here, I just plug it up with a 9-volt battery.
Well, there's 2 ports for the Arduino. You're using the Uno 3, correct? The R3?
The Uno 3? This is Arduino Uno.
The R3.
All 3. I don't know.
Yeah, so the Arduino has 2 input ports. There's one that takes more than 5 volts, like 5 to 12 or above 5, sorry. And there's one that's specifically for 5. So I'm guessing the one that you're using is 5 volts. The USB one, like with that weird that goes into it, like the USB kind of one.
Yeah.
Like the hexagonal one. Hexagonal, excuse me. It's been a while since I've said that word. It's been like 9th grade.
Yeah.
That's a 5-volt input. Because there's 2 inputs that it can do. It can adapt to either or. One of them is like, say, like that, a USB. Say, like you have that, like a rechargeable, like a battery pack, and there's one if you want to do, say, like a 9-volt battery that goes into it. It needs its own specific adapter to go into it, so it can do both. And so, long story short, it's 5 volts. I feel like Dr. I feel like Dr. Griffin.
Ship by Tuesday, Justin.
Me and Robert were talking. Do you have like I haven't looked through my files yet, but do you have the presentation from last semester?
I wonder if it's still on that drive that was made. I think you made it, Hassan.
Yes, I did. Yeah, we still have access to it. Let me double check. Let me go to mine.
So I guess tomorrow is when we want to do the recorded presentation.
Yeah, and like work on the PowerPoint, go over recorded. Yeah. It's like a practice one. It's just we just want to practice it on our own before the practice, right? And then next week, before we go in the official one, we turn in the PowerPoint, and then we also do a pre-recording of the PowerPoint. Any of us. That's just in case he's not able to save or submit any of that during the official one. So tomorrow, we can create a PowerPoint, go over, throw in the slides, what portion we're going to take. And I'm free for most of the day after my exam. I think my exam ends at like 9:25 or 9:30 in the morning. Okay, nice. But I have probabilistic systems at like 9:05 or 9:10 till after.
I'll be free from like 1 and on tomorrow.
Okay. But I'll be free, I think, after, let's see, an hour and a half, like 11:30-ish, I think. 10 something. 10:05, I believe, yeah, and afterwards. But you said 1, I can do that. I can work with you on that one. Totally fine after 1. What about you, Justin?
I'm free all day.
Okay.
So if I remember correctly, he said that the real interim project presentation we're doing is on Tuesday, 1 week from today.
Yeah.
I thought that's what he said in the meeting.
Okay.
Yeah.
Yeah. The real one's on Tuesday, a week from today, but tomorrow we're going about it and have to turn some things in anyway.
Mm-hmm.
Like he's opening up a Dropbox to where we have to turn in a pre-recorded presentation, and then we're supposed to go about it I don't know. I mean, he says practice, but then he acts like we're still getting graded on this part as well.
Okay, dudes, I still have the presentation from last semester on here and the OneDrive. I can reshoot you guys the email for that, or the email address. You guys still have access to both of it. I don't mean to cut you off. I'm sorry, dude. I have super bad hearing, dude.
I think I already can get to that. Let me see. I don't know. That's from software.
Isn't Mirror's this semester going by a little quick?
It's going by quick, but really slow at the same time. It's been very difficult to keep up with all the work on eCourseware. I'm getting it done, but it's really just again, my probabilistic systems class is destroying me mentally.
Last semester, that's what I spent the most on. Yeah, that was in senior. No, and that was while in professional development and junior projects.
It's taking up, I'd say, 80% of my efforts going towards that class. And that's why I feel like I'm kind of picking up the slack on everything else, and I feel bad about it. But it's dude, what else can I do? I really need to learn that material. The exams and the quizzes and tests take forever, and trying to understand it. I'm pulling my hair out half the time.
Well, yeah, the last thing you need is to be tripped on your way out the door.
Yeah. All right, so I just sent you guys an email for that senior, and it's got the presentation in there from last semester. We can use that. It's from April. And then we can add in what we've done this semester so far. We can work on that tomorrow. My biggest thing today is really learning how that Bluetooth adapter connects with the MIT app. Justin's trying to see how he can get a 5 to 1.4 volt for today. And you put the track together. I still haven't turned in the functional decomp. Have you guys done that?
Yeah.
I thought we turned that in a while back ago.
Yeah, we turned that in a long time ago.
Not functional decomp, excuse me, cost tracking for today. Have you?
No, it's not due till midnight, I believe.
But it's just a one-person turn-in thing.
Oh, really? Just one person? Oh, okay.
Yeah, same for the peer review.
Oh, really? I already did a peer review.
I think each one of us turns in a peer review, but
okay.
For the other two people, but
cost tracking.
Oh, the other one's a group turn in. Okay, my bad.
This is the cost tracking that I threw together. So I just did for these dates, and then I added these. Let's see here. This will be the track, and then some of these hours right here is your research is on. I added those hours.
I don't know. I gave you a random number. I don't want to say random because I know I've put in a few days looking up at different oxygen sensors, hydrogen sulfide sensors, carbon monoxide sensors, and going from different website to websites, trying to see what the difference are with different models, including so just overall, that was I don't want to say arbitrary, but kind of an arbitrary number.
I think this is the thing. I mean, even to myself, I haven't been doing very good tracking on how much exact time I've done on each single day. So these are rounded numbers at the moment.
Okay.
And these are I've put these numbers to the days as almost close as I could to the exact day. Now, they could be off a little bit. I mean, I put when around a few days before I got the track back from Roberts, I put that there on that day for you, and then
we worked. I think
we text back and forth about this or that on the app developer app, and you said you were going to use those times. That's why I put those times for those days.
We also worked on the functional decomp. All three of us threw together. Concept development, we did that together. Requirement specification, same thing. All three of us, and
Dude, not gonna lie, I don't remember what the requirement specification was.
My memory is really, really fuzzy. It was just
I got all those things on my laptop.
Okay.
So
general team meetings, we kind of slowed that down for about 2 weeks, but picked up.
I mean, a lot of what we did was through text message. We didn't do
Yeah, true. But like I would go. Yeah, I would go to his classes. I still showed up for all of his Zoom calls, but they're usually like a minute or two. And because a lot of the class is still far behind, we were really far ahead of the other teams for a while, honestly. Just because like we bought the parts and put all like you guys put the track together, put the motors together, and we had
probably like a good thing too because it seems like this other stuff's going to take a minute.
Yeah, we were pretty far ahead of like even. I remember just like a few weeks ago, like 2 or 3 weeks ago, they're like some of the teams still haven't even gotten all their parts yet, and so we were way ahead of the curve.
Okay. Yeah.
So, Justin, you said you already turned in the cost tracking, and that was a group submission or individual?
I haven't turned it in. This is it right here. I'm about to I can just turn this in. This is what's on my screen.
I don't think it's. I think it does. Did he say it's a team?
Yeah, that's why he wanted.
Should show me.
Yeah, it didn't. That's what I'm trying to check.
He said to us in class today that there should be one person recording all the cost, and everybody should be sending that thing to that person so they can make this cost tracking. Which means it's a one-person thing. You wouldn't be sending everybody to one person, then everybody.
Right. But it doesn't show it as a peer submission though. That's
and last semester it was also a one-person submission.
Oh yeah, that's true. That's
why I was confused.
Okay. God, my memory's gone.
Yep. Could you do electronics still, Hassan?
Say again?
Could you still do electronics, Hassan?
Could I still do electronics? The class?
Like the class?
I was doing very well, and I didn't do good in the lab final, and I think that's what hurt me. I made a small yet significant error.
There's just so much memory involved. It's probably one of my weaker classes.
I did really good on the exams. I was the only person passing, but you got a name. God dang it, dude. But yeah, I think I was in his first iteration. Were you in there as well, Robert? First time he was teaching it?
With Dr. Robinson?
Yeah. Very, 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 very we are being recorded, but
yes, it was interesting.
It's Dr. Robinson. Hello there, children.
What's up, peeps?
Reminds me of Chef from South Park. Hello, children.
All right, I submitted the cost tracking just now.
Okay, sweet. I think what you have on there, like what we've done, we're supposed to be discussing like general team meetings, research for our presentation, functional decomp, construction testing. I think we're going to be covering all that in the interim presentation of what we've done so far.
I guess we should discuss changes.
Yeah, I think
changes.
Honestly, like when I'm looking through this right now, you get to the abstract. We basically do the same thing for the abstract. And we get right here to the introduction. We say gas detection of 3 gases. Then we explain the roadblock, the oxygen sensor, and the fact that we're going to add another sensor.
Right.
How we're not using oxygen sensor, right?
Right.
Yeah. So that's the thing we're talking about. Like, what sensor we're going to add in its place?
Well, we're going to talk about what the roadblock is and what our plan is to do that. So we say that, listen, we picked a sensor that was going to go over 21% oxygen level which is the natural oxygen level at room oxygen level, which is 21%. Now, any other sensor will only go to 21%. So the sensor that we chose was 25% to show that the oxygen level is greater than what it's.
Here's the thing,
is, which would make it more explosive, which is the upper explosive limit.
I think what it is, those oxygen sensors are used for is like, say there's a fire, right? And fires, it's a combustion reaction, so it's consuming oxygen, right? You could probably tell the intensity of the fire or like how dangerous it is by the lack of oxygen in the atmosphere in a room.
Well, it's actually the more oxygen, the more dangerous it is.
Right. But like, I'm guessing like if it's already burning, like in some scenarios, I was watching something recently, like say there's a house, there's a fire in there. And if you want to, they're really hesitant about just busting doors and opening because that sudden rush of oxygen, because that fire would have ate it already. Because it's already oxygen deprived, but there might be embers still in there. And then say they knock down a door, all of a sudden, that huge gush of oxygen from the outside might come in and like it'll reignite a huge fire. That's why I'm guessing why that maybe that sensor's like that. I'm not entirely sure, but that's like what I was thinking about why it works. Some of them work like that.
Well, yeah, that's why I think these 21% though, anything over 21% requires this special device on the inside, and it's like it's a bunch of money. And the one that we picked was the cheapest one that would go over 21%. And the thing is it for our application it doesn't work. So what we're trying to do is find, and now this is where we add that we have these 3 other sensors. We're also going to add a temperature and sensor, and then we have these other 3 gas sensors in mind that we're going to replace with that. Still get 3 gases. Now that's something that we have changed. Now in the mobility and how the robot moves, we're still using the motor drivers. The thing is our original plan was that this bot would be able to go upstairs and things like that, but due to COVID, we really didn't have access to cheap enough parts to get a bigger track. So we shortened our track and made it smaller. That's why we chose the one we did, because it was the only thing under $120, big enough for the size that we needed. So that's why we chose that one. Now, so we would say that for our mobility, but we're still using the same motor driver.
I think it costs like $210, if I remember the track.
It might, but I don't. It might have cost that much, but what I'm saying is the reason why I picked that one was because the other one that we were going to use, we can no longer get, and the next one that would actually go upstairs, the motors that I have, was about $700 or $800.
Right.
And I mean,
about
4 feet.
That's a good reason.
So cost-wise, that was just not feasible. Now,
that would have taken forever to build.
Well, it was a kit just like that. It just was bigger. And I have the motors from the lawnmower that would have been able to move that thing around and all. It's the same motor driver. So